All right, is with pleasure for the next Ziffo talk is going to be conducted by Max and Bugs. So Max, who is the lab data automation practice manager, who's been with Ziffo now for 8 months. However, prior to that, I had the pleasure of working with Max both at Dotmatics and back in the day at Biovia. Not Merck, by the way. And then Bugs, who's the VP of Solutions, who has been with Ziffo for 12 years. Prior to that, he was at GE Healthcare. And together, they're going to provide us with information on lab data automation at Ziffo, an accelerated service solution that solves a difficult technical challenge. So over to you guys.
Hey, thanks, Margaret. So something the other presenters didn't know, that there was a prize for the longest title. And sorry for that, you lose. But in all sincerity, this is kind of everything you need to know about this presentation, right? So first of all, Ziffo is playing in the lab automation field, and there's a lot of really exciting work going on. And what we're offering is a accelerated services solution build. And the last bit of it kind of re-emphasizes what Abhinaya said in this morning, that it is kind of really a sweet spot of what Ziffo does, right? The intersection of science, data, and technology. And I think there is not really that much you have to say about what this problem is. Right, it has all the hallmarks of something that is really difficult to achieve, right? The instruments as a data source are inhomogeneous, they are distributed, they are not constant, they are constantly evolving, and they produce data in different formats that represent the same entities. So in terms of what you're really trying to accomplish is digital decoupling, basically put the data into a place where they can be consumed by the data consumers, and verification of the data, really, which ties into a lot of what we've been talking about, right? That this data needs to be made operationally available to efforts in whatever it might be, data sciences, analytics. But there's, of course, also lots of compliance implications for that. And then the other part is best practices and collaboration, right? That as we are moving more down the digitalization route, there is, of course, an effort to streamline and optimize the way how we are managing data and dealing with it. So at a very large macro level, what that means for the IT infrastructure is that, of course, there is going to be a certain piece needed to basically do all the operations on the data in order to get them into this harmonized data storage where they can be then consumed by other applications. So there is, of course, the data extraction and data acquisition part. There's the data standardization, metadata enrichment, ontology annotation, linking of data, and then, last but not least, knowledge work. But if you manage to do all of this, there's, of course, huge implications on impacts on data quality and time savings. So this is kind of Ziffo's reference architecture that kind of talks about the digital decoupling. Right, there's on the bottom the master data and semantic layers, and then three main classes of data sources. Right, there is the scientific platforms, there's external data sources, and then of course the instruments, and that's where basically the lab data automation fits in. And if you think about what are kind of the boxes in which lab automation plays in a very narrow sense, there's of course the raw data and the process data. And in a very narrow sense, this is kind of the task of lab data automation, to basically standardize this data so that it is basically available independently of the instrument format. But at a much larger level, or at the macro level, it kind of touches on all of these different systems, because if you just think about, and I think we have already illustrated this today sufficiently, if you think about what glues this together, and this is what Aishwarya always calls like the breadcrumbs that connect the data together. Yeah, if you just focus on the sample information as your most basic connecting element that basically ties the lab data back to your experiment, they're actually dispersed, right? In an ideal world, everything would be in your scientific platforms as a system of reference that basically encodes the sample information alongside with your experiment definitions. But as soon as you're bringing external collaborators in, they will have, of course, that information encoded there. And then, more importantly, when you're thinking about lab automation, so the robotic side of it, you're now, of course, giving the responsibility of creating these samples to the robots, because they will be creating samples as part of their processes. So this is the one complexity that basically exists beyond the pure data standardization problem. The other one is, of course, the life cycle of the data, right? That before a data or a set of lab data becomes something that you want to track, there is, of course, interventions, right? There is business processes, which could be review processes. And then there's, of course, standalone analyses that may live in a specialized piece of software, right? And to track all of this is yet another challenge that we need to keep in mind when we're really thinking about lab data automation in the holistic sense. So what is Zifo doing? So basically Zifo is looking at this more from a practice point of view and saying, well, in order to make this happen, we need to probably build accelerators in all three areas that affect the solutions build. Right? We talked a lot about your digital strategy and change management and business process optimization. So there has to be a consulting aspect to that. And now we have basically accelerators in terms of having people who have been around the block, who have done this quite a bit, who know the right change management processes, the right data governance, and other aspects like data standardization strategies. And this could, of course, be something that exists on its own, right? This is something that Zifo can provide to organizations like yours. Then there's, of course, services part, right? We have services technicians who are very knowledgeable in these areas, and they may service a system from one of our partners, like Tetra Sciences. And then last but not least, and this is an area that has basically grown out of building systems one-off. We've built out certain technologies to provide certain aspects in this middle layer. And maybe I should also clarify that the only thing that we're focused on is in this middle layer technology, not in the cloud data platforms, but really only the parts that kind of relate to the system integration problem on steroids, right? And there is scalable cloud architecture, a software that needs to be enterprise grade, interfaces, and workflow management. And this is going to be Buck's role to basically explain you how this is all done. Basically, we took a stack of state-of-the-art cloud technologies and built this up from that end. And this is actually quite a sizable effort within Zifo. So basically, we have two teams, one that is aligned on the services side. So we actually think about the building of the instrument connectors and parsers as a services offering, and that there is a team built out that can really tackle this and basically build these parsers at scale. So that when you come in and you're looking at an initial assessment, that you can basically close this gap of instrument connectors that may not have off-the-shelf parsers available yet. They also basically do all the requirements workshops, the project management, and all the other work that is customer facing. And then we have a second team of cloud engineers, and there's basically people that were hired with the specific purpose of building scalable cloud architecture. And Bugs is, of course, overseeing both of these efforts and has basically encoded his years of experience into this. So this whole, as I said, this whole thing started 8 years ago. We have now done 3 years of concerted investment, so there's a sizable number of FTE years that were put into this. And in terms of compliance, this is built to various standards listed here below. So, as I said, one of the key challenges in building out this lab data automation is, of course, being able to build parsers at scale. So far, we have 200 plus parsers available. We have also a very ambitious goal for the end of the fiscal year, which is not the calendar year, to basically boost this up to 500. The other thing is that from the tech side, we basically categorized out our build efforts around 3 specific areas, and they can be deployed in a modular fashion. They can also function completely standalone, so I encourage you to talk to our partners at Sapio Sciences, where they basically just released a new product called Jarvis. And we're basically OEMing our technology so that they can basically push a data stream through Jarvis to basically accomplish data standardization. So, but in terms of these pre-built capabilities, we have 3 big areas. One is the instrument data acquisition and standardization, and that also includes the connectors to productivity systems like ELN LIMS. Then the other one, which basically addresses these 2 other challenges that I outlined, the data synchronization and the workflow enablement, which is the lab workflow orchestration capability. And again, Bugs is going to explain a little bit more what this means, but behind the scenes we have a BPMN engine that can basically manage the data flow through a multi-stage workflow. And then last but not least, we have a small utility program that can basically push data into an S3 bucket in case there's no cloud data platform available to put the data, and then basically link these results to an ELN. So with that, I have ended my part of the presentation, so I'm going to hand this over to Bugs.
Good afternoon. Can you hear me? Yep. Okay, good. My name is Bhagavathi Rajan. To make it easy, you can call me Bugs. I'm based out of India. I lead the solutions team. I've been with Zifo for the 12 years. I've talked to several of you over the period on the ELN and LIMS related aspects, where I used to work on a number of integrations. That's like the 8-year effort that Max talked about. So we used to work on helping customers to integrate instrument data, application data across different systems, to extract data from the ELN and LIMS, feed it into the data stores. So that's something I have been doing for quite some time. And that's where we saw like we were doing the same thing again and again at different customers, just using different technologies, or in several cases we were able to reuse code, and we were like, why are we doing the same thing and again, why not just try to build an accelerator toolkit that we could reuse across customers, help our customers to solve this challenge quickly. So that's how this idea was born in terms of building a toolkit and the parsers library as a services on top of it, and help our customers to accelerate and be able to solve this technology challenge fairly quick. That was the whole idea behind this. And some of the challenges that we are trying to solve through this. One of the key aspects is the instrument world. The way I call it is, it's a jungle, right? You have variety of instruments that date back like 2 or 3 decades, and you could only take some reports, could be like PDFs, Excel kind of ones from which we had to take data. And then there are some of these legacy instruments where we could communicate only through some of this DLLs, the old Windows technology aspects, or through .NET kind of code. All the way in recent days, we communicate through REST APIs, through OPC, some of the serial port communication. So what we had seen is we had to support a variety of technology aspects, different type of files, and we needed a solution that could essentially be able to support the different type of connections that require, the different type of data that's required. And ultimately, we had to take it to a standardized format. And this is something, the way we initially started, we focused on some of the standards that the industry has been attempting, like Alatraf and Animal, etc. So we have been trying to support the final data conversion to Alatraf and Animal. And what we had seen is, again, from a standard adoption perspective also, the industry is still far behind. So what we have done is we have just stopped it somewhere midway in a JSON format. So we take it to a standardized human readable format that could be fed to the data stores. And if you're looking at adapting some of your own standards, your own ontologies, or if you're looking to take it to some of the industry standards like Alatraf and Animal, we should be able to support it. So the whole idea is being flexible, be able to support and help customers to implement the standards, ontologies that they are looking to adapt as is required. So this is like 2 elements. One, you should be able to take the data from a variety of input data sets and be able to convert it to one of those standards the customer is looking to adapt, either an internal standard or an industry standard like Alatraf Animal. And the other part is this need to be done at scale. When you're looking at enterprise scale, we are talking of sites that spread across the globe, hundreds of instruments in different sites. We need to be able to manage a large workload. And we have cases like there are instruments that feed gigabytes of data, right? 10 GBs, 50 GB kind of files that come from like the flow cytometry files or the image files that we should be able to occur and transfer it over to the cloud. And there are like pretty high volume, low intensive data sets that need to be continuously polled and integrated. We need to be able to handle that extreme, being able to handle huge data movement between the cloud and the on-prem edge devices. That's one major challenge. And on top of it, we had seen like several sites where, despite the recent advancements, we go to a site and the internet is still not stable, right? The connectivity to the instrument is still a major challenge, and we have to still work through that aspect also. So we had to work through the data problem, we had to work through the connectivity problem, and ultimately get the data to the cloud. This is a major use case challenge that we have been going across at multiple customers. It's kind of like the internet connectivity. In the initial time when I started with it, I used to think like maybe it's 1 or 2 customer site problem, but we have seen it like consistent. Several customers have it. There are several sites where this is a consistent problem when it comes to the instrument connectivity, and we have to solve it. And I think I already talked about it in terms of the volume of data. And the way we also try to generate the data, the way we approach it is not just one specific instrument data. The value that we see is when we generate the data with a complete context. Let's say you are doing your chromatography run, right? You start your analysis pulling in the list of sample requests from different sites. You're kind of bringing a plate together and preparing the plate. What we had seen is people don't even have the link in terms of the sample info that Max was talking about. When the plate is prepared through a robotic engine, typically it's like a work list that's generated. The sample information in the LIMS or ELN is not really linked to the plate that's being prepared in the liquid handler. And from there, it goes to a chromatogram system. The run is done and the result comes back. And then people export that result manually, kind of link this sample information and key it in the ELN or LIMS. That's kind of a typical flow that we had seen, or people do some data massaging in between before the data goes into the ELN and LIMS. What we are trying to do is, can we generate the complete view of this data all the way from the initial request to the final result that goes back to the ELN, including your reference. If we can just generate a full view of the data in a single document where you are able to get your experiment context, could be a project or a product, the associated samples, all the results that came back, and the inference that you made out of it. If we can generate a single view, right, it becomes much more powerful in terms of how we are able to look at the data. And that's where we look at this as not a single instrument challenge, rather focus in terms of complete orchestration, being able to orchestrate the flow, connect the data across, ensure it's metadata contextualized, then you are able to view the whole data in a holistic way. So those are like some of the major aspects that we try to solve as part of this solution. And from there is how we have kind of built this. So the underlying core platform, it focuses primarily in terms of how you organize and how you are able to manage the data, being able to get different labs and store your data by labs, and being able to set the security and manage the metadata. You probably will have a MDM system. You need to be able to link both. So that's something the underlying platform does. Rest of it is kind of plug and play. If you can choose some specific components, that's how this is architected. But the most critical part is the connectors. That's one of the biggest challenges that we faced in terms of, are we going to keep it centralized in a server? Are we going to keep it at the edge? And finally, we kind of have come with an approach where it can be hybrid, where we can keep it in the cloud, we keep it in the cloud, but we also deploy clusters that will just occur the data and transfer it to the cloud within the edge, so that even if there is an internet connectivity challenges, it would still be able to occur the data, keep it, and then transfer it over to the cloud when the connectivity comes back. So that way, from a fail-safe mechanism perspective and more from a performance perspective, we are able to handle it. So we put different clusters in different sites. Could be like, say, US, Europe. You can have different clusters to occur the data within your on-prem edge devices. And then from there, it would transfer to the cloud. Once it comes to the cloud, in terms of transforming it, in terms of orchestrating it across your business roles, that's something we could manage centralized. That typically does not need those connectivity challenges. So that's something we solve it through the cloud-based mechanism. So essentially, for orchestration, we use a BPMN. It's a low-code platform. If you understand the BPMN, you will be able to build your own orchestration workflows and build your business rules and orchestrate the different flows as per your assay protocols. So different assay protocols need different orchestration workflows to be built. So that's something you can do. And each of that, basically, like, say, a liquid handler connector, a CDS connector, a connector to, say, your ELN, each of those are components that are pre-built, standard available. And then you could just kind of assemble, put your business rules, and orchestrate the flow. So that's how typically it works. And this is something I'll keep short. So from a scalability standpoint, we have used different cloud technologies like AWS or Azure kind of ones, but all of it, we use our Kubernetes platform where it could adapt scale. So larger the number of instruments and the volume of data, it would auto scale. It will themselves add additional horsepower and manage the load automatically. So this is something that taken care in the cloud, and it could scale, manage in terms of the overall load and manage the overall load with the additional horsepower that's required. That's how it's done. I think, yeah, so that's how we solve this technology challenge. Having kind of a modularized approach, we use some of the industry standard cloud native data engineering middleware tools. We use Kubernetes platform. We use some of the on-prem middleware tools that we have got, and kind of bring everything together. On top of it, we have the instrument parser service that kind of continuously they build the parser agents that's required, and we bring that together to help accelerate the whole challenge. So I'll stop here. We'll answer any questions that's required.
Questions? Anyone?
Yes.
Is one aspect. There's also the requesting of services for, which happens, like how do I request analysis, and then it kicks off some downstream processes. Is there requesting components you're thinking about where you can connect that to, or is there requesting?
So there is an LRMS component, which is basically, it's something we just finished the work. So yeah, we're not talking about big time, but it's basically, again, we use the same BPMN because there are different type of requests that need to be managed in an enterprise organization. Could be like a compound request, or it could be like a media buffer request. Different groups uses different type of requests, and you need to be able to design and manage the request in a centralized way. So that's part of the system capability where you could generate the request and be able to spawn the assurance from that.
Is that like a step function, Lambda function? What are you?
We pretty much use a microservice component in Kubernetes, not Lambda. It uses a BPM. Because again, each of them need different UIs, and we just use a low code so that you can do it easily.
Any more questions? No? Okay, thank you guys.
Thank you.